Here is a single matrix. Each row represents a user, and each column represents an item. Let's turn the cells for the products purchased by each user black. At first glance, the black cells are scattered in disarray. Now, let's rearrange the rows and columns so that the black cells are grouped together as much as possible. When we do that, several rectangles appear. This process is called rectangular partitioning. This is a process for grouping users who have purchased the same item. Now, let's rearrange the rectangles so that they are in alignment with no gaps between them. This way, you can see the relationship between users and items at a glance. The users in Group 1 have purchased item Group A, while the users in Group 2 have purchased item Group B. The users in Group 3 have purchased both A and B. That means if you recommend B to Group 1 and A to Group 2, they may buy the respective item groups. Discovering such relationships can be very useful when analyzing online shopping and social networking services. By the way, the number of users and products can grow infinitely. When that happens, humans and even computers may not be able to handle this process. Is it possible to find the optimal rectangular partitioning even for an infinite matrix? NTT Communication Science Laboratories have been working on this problem from the perspective of mathematics and data science. This is how the rectangular partitioning of a 500 by 500 matrix is optimized. In 2020, the laboratories presented a method that can discover a stochastically optimal rectangular partitioning process even for an infinite matrix. There are two key features to this method. The first is the introduction of a projective model on rectangular partitioning. This model finds similarities between matrices of small size and large size. Ultimately, the model can represent a matrix of infinite size. This has made it possible for computers to handle matrices of infinite size. The second key feature is the use of a sequence of natural numbers to find the optimal rectangular partitioning. The first step is to assign a natural number to each rectangle based on a certain mathematical procedure. Then, processes of rectangular partitioning can be represented as sequences of natural numbers. These sequences of numbers are called Baxter permutations. The use of Baxter permutations allows us to replace the problem of finding the optimal rectangular partitioning with the alternative problem of finding the optimal Baxter permutation. In other words, a geometric problem can be solved using algebraic manipulations. We have established mathematically that this method allows us to search for all infinite variations of rectangular partitioning even when a matrix is infinitely large. Currently, we are extending the technology so that it can be applied to 3D arrays. This technology can be used for AI-based data mining. In time, within huge amounts of data, we may make great discoveries that are far beyond human capabilities or imagination.